There it goes. We're working. 6 frames per second. All right. Lexi, turn around. All right, we're going to do lesson 2.4 now, which is something a little bit different for you. It's called estimating sums. Now, in estimating sums, we're going to use your ability to do an estimate to find out what answer should be, and you should know where you should estimate and where you shouldn't. Okay? Now, so what does the word sum mean, Tiana?
Number.
No, not quite. Kristen?
The answer of an equation.
The answer of an equation is correct to a part. It's the answer to a certain type of question. Not timesing. Not timesing.
Oh, I know. Multiply.
What's the other?
I think it's Mrs. Popwich taught us.
Yes, I know. But that was a long time ago.
Yeah.
Sum is the answer to a type of question.
It's all the numbers.
No. Thomas?
Addition?
There you go.
Oh.
Sum is the result of adding. When you add something, you get a type of an answer. We call that getting a sum. There's also a word for multiplying called product. There's a word for dividing called quotient. There's a word for subtracting. That one's called difference. So, now the next question. What is estimating? What do you think, Cole?
If the numbers are like 19 and it's like in the jar, if it's 16 in the jar or something,
Okay.
and then you say numbers again.
Okay, so you're making an estimate of the number of jelly beans in the jar there. But can you turn that into a definition that I can use, Cole?
There's 6.
No, you're thinking of word problem. All right, what do you think, Chase?
It's guessing something.
Okay, it's the result of guessing at something. Now, I have to add something there. It has to be an educated guess, right? You can't use numbers for your guess which are way off. You got to try to be close. That's where estimating is helpful. So, for example, if I wanted you, without looking around, to estimate the number of legs on chairs and tables in here, don't look, all right? What would your estimate be? Put your hand up when you think you have it. All right, Tristan?
8.
8 legs and chairs, okay. What about you?
I estimated. I estimated
4.
4.
14, okay. Colby, what's your estimate?
46.
46. Cole?
51.
51. Raven?
30.
30.
4.
What about yourself there, Ted?
23.
23. Lexi?
42.
42. Tiana?
38.
38. Chase?
40.
40. What about yourself there, Teddy? 45. Noah?
I think there's about 54.
54. Thomas?
58.
58. All right.
Let's see.
What if, remember I said estimating has to be a reasonable answer. What if Marie estimated 6,000?
She's way off.
Okay? She's way off, isn't she?
Yeah.
Now, is 6,000 an estimate? Not really, because it's not really an informed, knowledgeable guess. Right? There's about 120 legs in this classroom.
What? I thought you said desks.
There's more than that, sorry. About 180, 160, 160.
Oh my
Legs.
God.
No, legs.
Legs.
On chairs and desks. There's 4 on your chair, 4 on your desk, so each person has 8. There's about 20 desks in here. 8 times 20, about 160.
I was going to
Okay?
say 100.
Now, that is an educated guess. You have to be close. There's more than 20 desks in here. All right? We're going to do estimates, so let's turn around, by using some rounding skills. The rounding is finding a close number to the number you were given, which is easy to add. So, for example, is 235 closer to 200, or is it closer to 300, Cole?
200.
That's correct. It's closer to 200. All right. What's halfway between 200 and 300, Tristan? 250. So you can use that as a guideline, right? Is 235 greater than 250? It would be closer to 300. If 235 is less than 250, it's going to be closer to 200, right?
Yeah.
So it's closer to 200. So you can round 235 down to 200 when you want to help add things, because 200 is easy. What about 489? Is it closer to 400 or closer to 500? Tiana.
400.
Right.
500.
What's the halfway point, Tiana, between 400 and 500? What's this point right there going to be? Pardon me? 450. Now, 450, is this one greater or less than 450?
That's
489 is less than 450.
greater.
More than 450, so it's got to be closer to this side over here, which means this number right here, 489, is closer to 500.
I gotta wake up.
You do want to wake up? Okay.
Yes, you do.
All right, here's another one for you. Focus and tell you, okay? Next one, 2,578. It's the nearest 1,000. Let's see if you can do, let me put the rest of it in. Noah.
There's 2,000. There would be 2,000.
Right. What two numbers did you have to choose from, Noah?
From 1,000 and 2,000.
Really? On a number line, if I had a number line, I'm just going to count thousands, right? Here's 1,000, here's 2,000, here's 3,000. On this number line, would you put this one here into area A, or would you put it into area B, Noah? Where is 2,000?
Area B.
It's in area B. So this number right there is somewhere between these two numbers. So you're choosing between 2,000 and 3,000. Is it closer to 2,000 or 3,000, Noah?
3,000.
Why do you say 3,000?
Because it's over 2,500.
Exactly.
So even if it would have been 1 over 2,500, it would have been closer to 300.
3,000. Excellently put. Okay. Yes, do you have a question, Raven? You sure can. Let's look at the next one. Oh, sorry, that's the question. Look at that one. All right. 5,472 to the nearest 100. To the nearest 100.
1,000.
Oh, sorry, 1,000. Yes, fire. What do you think?
I think that is closest to 5,000.
You're correct. If you take a look at the number scale, here is 6,000, and here is 5,000. Halfway is 5,500, and 4,000, that's right around here somewhere. So it's less than halfway, so it is closer to 5,000. All right, there you go. 772, the nearest 100, Lexi. 800 is this one right here, isn't it? Okay. Okay, now we're going to use some rounding stuff, or sorry, rounding skills, and put it, estimating together with it. So here we are. Haley and Brooke went shopping. Haley spent $479, and Brooke spent $732. Estimate how much they spent together. Now I'm going to work your way through this, okay? So keep your hands down. First thing you need to do is round Haley's number to the nearest 100. So Haley is right here. What is the nearest 100 for Haley? What is it, Kristen?
500.
500, okay? So we're closer to 500. Good job. Now, what about Brooks? Closer to what? 700 or what? 600. So which one is it closer to? Yeah, it's actually between 700 and 800, right? So it's less than halfway, so it's going to go to 700, right? Now what you're going to do is add these two numbers together. Now, 500 and 700 gives you what?
1,200.
There you go, 1,200. That's a lot easier to add than this number here and this number here. So we're doing an estimate. So roughly, how much did they spend? $1,200 together. Is this the exact number of dollars they spent?
No.
No, because we rounded them off to find out, right? So if you take a look, there's your answer, and there's sentence. Let's add another problem. Meg and Kate are having a competition to see who can dirt bike the farthest during summer vacation. Meg said she traveled 604 kilometers, and Kate said he traveled 760 kilometers. How far did they travel together? Okay, so what do you think our first step's going to be, Tristan?
To round up Meg's was 100, not 600.
There we go. Good job. You're so, wow, good. And the next one's going to be Kate. Lexi?
You would round it up to the nearest 100 with 50.
Good job. What do we have to do now? Ted?
What's the answer?
You remember, well, you tell me what the answer is, and you gotta tell me how to get it.
Okay, then I don't know.
Well, you have the answer. What answer did you have?
Oh, it was, what?
1,300? Okay, it's one possibility. Cole, what do you think the next step is going to be? Now add the two distances together. You're pretty good. When you add these together, Teddy Hughes, what do you get? 1,400. And you need a sentence. So together they have traveled about 1,400 kilometers. Next problem we go to now is tell whether an estimate is too high or too low. So let's take a look at the first one. 1,268. Okay? What I want to do here is estimate the sum of these two things. So, is this estimate higher or lower than the real sum? And how do you know? Tristan. Okay, why is it lower?
Because it's a rough translation of what the answer is.
Beautiful English, but I don't understand it.
It would be rounding up the hundreds, closest, rounding up the numbers to the closest thousand.
Okay, so you did that, that's correct. This is the rounding we did. So is this 600 too high or too low when you compare it with the real number?
Who knows?
Why do you say that?
Because 5,234 is higher than
Okay,
1,000.
that's right. So this one's higher, so we actually have moved this one down, haven't we? That number's been rounded downwards.
And 1,268 is rounded down.
There we go. So this one here is rounded down to be less, and this one here is rounded down to be less. When you add them together, 6,000 is going to be less than the real number.
104, it's more than
It's
1,000.
more than that, okay? All right, so there we go. Let's try this one right here. So, is this estimate high or low?
No.
Okay, what do you think? Noah.
Well, the 8,000 is good, and the 4,689 is correct.
I know it's correct. That's not the question. The question is your answer, your estimate, sorry, is your estimate too high or too low when you compare it to the real answer?
Too high.
Too high. Why?
Because they rounded it to the higher.
All right, so this one has been rounded up, right? This one is rounded up also. So both of these get increased when you do your estimate. Then when you put them together, you're going to have a number which is too high. If I can hear you whispering, they can probably too. All right? So this one here. Now, here's the question. When would estimating numbers high be a very good idea to do? When would you want to estimate high? Lexi?
Maybe if there's a jelly bean jar
And you want to estimate high, why would you not want to just be perfect? I want my estimate to be high. Why would I want it to be high? Lexi? No? No? Okay, Tiana.
Like if you're estimating how many crayons are in the box in front of Tyra, it would be high because there's a lot of crayons in there.
Well, I'm not getting my point.
No,
Maybe I'll tell you the answer and this will help you. But you have to be on time for something. And you have things to do. Maybe it would be better for you to estimate each one of your actions as being a little high. So, let's say that you had to do the laundry. And you had to vacuum. All right?
and you had to wash the floor.
And then wash the floor. Okay, 3 things. Okay? Now, here's the thing. It's 2 o'clock, and you want to do this and make sure that you're done in time for, say, 6 o'clock. All right? Now, you have to be done by 6 o'clock. Someone calls up and says, hey, Noah, what? At 6 o'clock, we're all leaving on the plane to go to Bermuda. We're going away for a whole 6 years, all expense paid vacation. You get $1 million and you can do anything you want. Are you going to make it, Noah? So Noah starts thinking, am I going to make it? Well, here we go. Laundry, it's going to take me about an hour. Vacuuming is going to take me about 2 hours. And wash the floor is going to take me about half an hour.
No, he's not gonna have time.
Is he going to make it?
Yeah.
Kristen?
No, she's gonna do 2 hours or one.
You think?
Yeah. She's gonna be a little.
1 and 2 is how much?
3.
And a half. So he's estimating 3.5 hours. How long does he have?
4 hours.
He has 4. Is he going to make it?
Yeah.
He is. Now, if he estimates low, let's say he estimates low on this by accident. Now he has a problem because there's only a half hour of squeeze room, isn't there? So if he estimates high, then he's going to be okay, right?
Yeah.
If he estimates low, what's going to happen if it takes longer? He's going to miss the flight.
And he won't be able to get $1 million.
All right? How about estimating what's in your gas tank? Do you think it's good to estimate high or estimate low when you have a bunch of gas? Oh, so you want to go somewhere and you think, well, I have about 3/4 of the tank. I'm going to round my tank up high.
You need to go to the gas.
What's going to happen if you're wrong?
Then you're gonna run out.
Run out of gas. So when you're estimating how much gas is in your char or your truck, you want to estimate a little lower than what's in there because then you'll be safely to the gas station. All right? Let's take a look at another option here. What situations would you never, ever estimate in? Ted?
Like in the middle of this.
Okay, well, sometimes you're asked to estimate, but yeah, if it says calculate, you don't estimate, do you? All right, so that's good. What do you think, Ken?
When you're too busy kissing Justin Bieber.
I don't quite, what would estimating to do that?
How long? Estimating how many kisses?
No, it's not. Now you're being silly. Now, when would you never estimate? Here's, Noah, you have an answer?
If you're sending something to the government and they need the exact answer.
There you go. Let's say the government tax man comes around and says, Noah, you made a lot of money last year. You owe us some taxes. If you don't give us the money on time, we're going to charge you and throw you in jail. Do you think you should give them the exact amount they asked for?
Yes.
Yeah, that's not a time. You don't estimate on your taxes, trust me. You don't. You want to be perfect because if they do an audit on you, you get in trouble. What about this situation right here? Do you think your doctor should estimate when he finds to figure out how much medicine to give you when you're really, really sick?
No.
Let me see here. Well, go always, you round up here, 100, 200 pounds. And you got to give the medicine for the neck for you, all you love. I don't know, 30-gram pill.
Sound like
Does that sound like a good doctor?
no.
No.
That sounds like a stupid doctor.
Exactly. What you want to do is make sure that Cole gets the correct amount of medicine, because if he gets the wrong amount, it can be seriously harming him, couldn't it?
And he gets
Especially if Cole was a baby and he was only 1 month old.
Oh, no.
You think when you give babies medicine, you got to be exact?
Yeah.
You bet you have to be.
Especially if you're about 100 or 200 pounds. Like
Well, I don't think babies are 100, 200 pounds. All right.
Be a sumo.
Let's see if you can estimate this number in your head.
I can.
The nearest thousand.
do it on a piece of paper.
The nearest thousand. No paper. In your head. Okay, just one second. Give everybody a chance to work on it. Okay, Tristan, what do you think?
My estimation is 8,000.
All right. So there's his estimate. What do you think? What's your estimate, Colby?
I'm just guessing. That's the thing in between 8,000 and 9,000.
So you gotta give me a number. What's your estimate?
8,500.
8,500. Okay, let's go on this one and see what the next step's going to be.
You did 850. That's 850, not 8,000. No.
Good. All right. So what we're gonna do is bring some quick estimates. 1,268. What's the nearest thousand that's closest to you? Okay, 1,000. Tyra, what's the next one going to be? 5,000. What's the next one going to be, Thomas?
2,000.
2,000. When you add all those numbers up, 1 and 5 and 3, you get 8,000. Okay, good job. Now, I want to talk about something. Colby said 8,500. Who had a better estimate?
Colby.
No.
Colby.
Here's why.
Colby.
Take a look at this one. How far is it for the 268 to get down to the 1? It's only about 200, right? What about 470? Get this one up to the 5. It's going up a little bit, right? But we took this one and dropped 500 off of it almost. So if I had just said, well, let's leave that as it comes to 500, I'd have had 1,000 and 5 is 6,000, 7 and 8, and this 500 right here, 8,500. Now, do you have to be that accurate? It depends. We were doing it to the nearest 1,000, so you didn't have to be. Here is, it's 321, there's not enough.